Hello students, welcome you all to my YouTube channel. As you know, in this channel I am coming near you with different videos of physics related to ICSE curriculum. Today, in my video, I am going to discuss about a topic called measurement. In this topic of measurement, we'll able to know what is a physical quantity, what is unit, types of physical quantity, properties of unit, how to write the unit, and also about some basic fundamental quantities. So let's start our video about measurement. First thing in the measurement, we'll have to know what is that measurement means. Measurement to measure. When we want to know the exact value, we need the measurement. So what you have to do in the measurement? Measurement time, we have to compare. One side we have to keep the unknown object whose mass, length, or any other physical quantity we want to measure. Another side, the known standard quantity. Means measurement is just the comparison between known quantity with the unknown quantity of same nature or same kind. Means if we want to measure mass, we have to take the help of kg. If we want to measure the length, we have to take the help of meter, the standard unit. So what we can say that unit, the standard, the constant value with which we'll measure, with which we'll compare. So the quantity of constant magnitude which is used to measure the magnitude of other quantities of same nature. One side will keep a 1 kg fixed weight and other side an unknown. So when the pointer will come to the middle or it will balance, then we can say that unknown quantity is 1 kg. Same way we can take in the meter scale or meter tape. So unit is used to compare a known thing with a known thing. This unit again divided into two kinds. So first one, the fundamental unit means that unit which are not having any relation with any other unit, or simply we can say which is independent, which is not depending with other, like kg will take kilogram, not depending with other. Meter we can say, ampere we can say. These are independent units, but some units are derived unit, means they are dependent on other. They can be derived, they can be calculated by using another quantity. So they are in the category of derived unit. So two type of unit. One is fundamental unit, another is derived unit. Next one, if we look, when we will take unit, what are the properties of the unit? Means in which type of unit we can take for our measurement. So first one, the unit should be of convenient size. Means we want to measure the length of a mosquito. That time either we'll use mm, millimeter, or cm, centimeter. We can't use kilometer here. Or when we are measuring the distance between one town to another, that time we are not taking the millimeter or centimeter unit. We are taking the unit of kilometer. That means we have to take the unit according to the convenient size. Next one, it should be possible to define the unit. Means in the ancient time we are using that handspan, we are using cubic. That all we cannot able to define. That means that type of unit we cannot take, which will not able to define, or it will change. Third one, the unit should be reproducible. Means we can get the smaller unit, or we can get the bigger unit, or we can say that we will get sub multiple and we'll get the multiple of the same unit. That type of unit we should have to choose. Another one, if we look here, the value of unit should not change with space and time. Means the length of the body is 5 mm. That 5 mm has to remain constant everywhere. Or if the body is of 10 kg, 10 kg has to remain constant everywhere. That type of unit you have to choose. If with the person, with the space, with the time, if the value change, that is not a perfect unit. So one, we got unit, and second, we got how to measure or the comparison. Third one, if we look at physical quantity. Physical quantity means the quantity which can be measured directly by using instrument, or the quantity which can be derived or calculated by using another quantity. Means one quantity which is independent, second which is dependent. And in this physical quantity, you will get two parts. First part, if you look your mass of this man is 87.5 kg. Here two part. 87.5 is the number. Kg is the unit of fixed constant magnitude, you can say, or fixed magnitude, you can say. Means mass of this body is 87.5 times more than 1 kg. 87.5 is the numerical value here. Kg is the unit. If we take the height of this boy, 1.4 meter, where 1.4 is the number, meter is the unit. Means physical quantity is the product of number or numerical value and the unit or constant magnitude. So when we take the physical quantity two type. One type of physical quantity which can be measured directly. Second type of physical quantity which can be derived or calculated by using formula. So we have divided this physical quantity into two types. First category is the fundamental quantity. Fundamental quantity with the independent. Fundamental quantity which can be measured directly. Fundamental quantity is that quantity which is not changed or related to any other physical quantity. Means if surrounding temperature 25 degrees Celsius, with the increase in length, with the increase in mass, with the increase in any other quantity, or increase in the volume of any room, the temperature will not change. Means temperature in the category of fundamental quantity. Second one, if we look the derived quantity. Derived quantity means derived quantity is that quantity which is related to other. Means we want to find area. We need two quantity, L into B. We want to find volume, L into B into H. If you want to measure density, that time it is the mass by volume. Pressure, if we take force by area. Means we need different other unit to calculate one. We need different other quantities to calculate one quantity. So that is in the category of derived quantity. Another one, system of unit. Means before some year, different part of the world were using different type of unit. So that type of unit used by a different region or a particular region, that is called system of unit. In that we'll get first system as the CGS system or French system. The people of France who are using this system, CGS, centimeter for length, gram for mass, as second for time. FPS system or British system, the people of Britain or the people of UK, they were using this, or Britishers were using FPS. Now also, because Britishers ruled to us for a long term, for that year, now also we are using these units. FPS, foot for length, pound for mass, and second for time. MKS system or metric system. This one used here, look, length, meter, mass, kilogram, time, second. Another one also, MKSA, where meter, kilogram, second, and ampere. That is also a metric system. But because different part of the world, they were using different type of system. So in the year 1960, the General Conference of Weight and Measure recommended a system of unit. System International D Units, or simply we can say SI system. This SI system they have given for all the fundamental quantity and also for all the derived quantity. So if we'll come to the fundamental quantities first. In fundamental quantities, they have decided 7 fundamental quantities. With that, 2 additional fundamental quantity, which is solid angle, or for angle we can say. Here if we look, 7 fundamental quantity: length, mass, time, electric current, temperature, amount of substance, and luminous intensity. Length having the unit meter, mass kilogram, time second, electric current ampere, temperature Kelvin, amount of substance mole, and luminous intensity candela. And 2 more for angles they are used. that for means construction time, or simply we can say engineering case, they are using that to quantity. So if we come to some derived quantities, in derived quantities there are many derived quantities where quantity and unit means some if you look the equation here, area, length into width or length into breadth, that time we are having the unit square meter, meter square. For frequency 2 unit, if you look here, hertz and second inverse. For force, if you look to 2 unit, SI unit is Newton, but we can say meter kg per second square. So kg meter per second square we can say to it, because it is a F equal to MA. So kg meter per second square. Pressure, if you look, Newton per meter square or Pascal, means some quantities are having 2 units, some are having 1 unit, but SI unit always that Hertz, Newton, Pascal, Joule, Watt, Coulomb, Volt, or Ohm. These all are there. We can say SI unit. Next one, rules to write the SI unit. Means when you are writing the SI unit, first thing you have to look, the unit name after the scientist are not written with capital letter, capital initial letter. Means usually when you are writing a scientist name or any name, the first letter should be capital in English grammar. But to write the unit, whether it is maybe from a scientist name or not from a scientist name, if you are writing their full form, you have to write in small letter. Means initial letter cannot be a capital one. Second one, the symbol of the unit named after the scientist should be written with the first letter of his name capital. Some units are having only one letter, some are two letter. If it is one letter, then that's it. Here one more condition apply is the unit name should be derived from a scientist name or named after a scientist name. Newton, capital N, Watt, capital W, Joule, capital J. But when you come to Hertz or Pascal, that time capital H, first letter, initial letter, Z, small z. Pascal, capital P, initial letter, A, small a. Small letter are used as symbol for unit, not derived from a proper name, means which is not from a scientist name. That time we are taking small letter like M per meter, kg per kilogram, S per second, liter, L, small l. No full stop or other uh, punctuation mark should be used within or at the end of the symbol. Means we should not have to use any full stop or comma after the unit. The symbol of unit do not take plural form. Means 100 kg also 100 means 1 kg also we will write kg. In case of 200 kg also we will write kg. Means we will not write any plural form. Means it is not that 10 kg s or kgs we cannot write like that. 365 kilometer, we are using the unit here kilometer, not kilometers. So unit cannot be. People look, when temperature is expressed in Kelvin, means Kelvin is a SI unit of temperature. Kelvin is the absolute scale. That time we are not using any degree. You cannot write 273 degree Kelvin or 512 degree Kelvin. But in case of Celsius, we are using degree Celsius. And when we will take any negative power, means meter per second, joule per second, or Newton per meter square, joule per Kelvin. So that all case, we are using negative power. Means meter per second time we'll use ms minus 1, or joule per Kelvin time we're using joule k minus 1, or people are having uh, Newton per meter square, n capital N small m minus 2. So we have to use the negative power. Some space is always to be left between the number and the symbol of unit. Means here you cannot write direct 2.3 m. We have to give certain space between them. 2.3 little bit space and m. Kg meter per second square. If we cannot write kg ms minus 2 full closed. And when we are writing two unit together, kgm, that means it's the product of mass and length. Means if we write meters ms, that means it is not meters, it is meter second, means the product of length and time. The only accepted unit symbol should be used. Means ampere we have to write capital N. If you are writing amp or am, that is not acceptable. per second S, not SEC or any other. So the recommended short form has to be used, and numerical value of physical quantity should be expressed in 10 to the power or order of magnitude. Means here if you look 136 13,600, we have written here 1.36 into 10 to the power 4. Means before the decimal only one digit will keep, and into 10 to the power some any other number you have to keep. This is called order of magnitude. When you are taking a bigger number, we are taking the help of order of magnitude. That time we have to take before the decimal only one letter, one number, and other 10 to the power. We have to take after decimal, we will keep other numbers and into 10 to the power. So if we are having 289, in order of magnitude it will be 2.89 into 10 to the power 2. Means that way we have to write all the units. So we will come to the next part. We got here what is unit, what type of units we have to use, how to write the unit of a physical quantity. Next thing will come now to three basic fundamental quantities: LMT, length, mass, time. Like to discuss about the length. What is length? Any 2 points if we take, the gap between that 2 points, the distance between that 2 points is called length. Length having the SI unit meter, and we have discussed one properties of unit. The unit should be well defined. Means there is certain definition of this meter. We will come to the definition of meter. Two definition will get. One definition in 1889 and second definition by taking speed of light. A meter was originally defined in 1889 by taking an alloy. Which alloy? Platinum iridium alloy. 90% of platinum, 10% of iridium. By using that alloy, they made one rod, and the point given in that rod, the distance between the two mark given in that rod is 1 meter. Where it is? In International Bureau of Weight and Measure, which is near Paris. So in that place, at that particular temperature, only the distance between that 2 points is 1 meter. But we have discussed the unit should not have to be changed with space and time. So this definition again changed when we got speed of light in air. So by taking speed of light in 1983, meter was again defined in terms of speed of light, because we know speed of light in air is 3 into 10 to the power 8 meter per second. Actually the value is 299,792,458. Means that number to we can say round off, it is the 3 into 10 to the power 8. Means light travel 3 into 10 to the power 8 meter in 1 second. So what is 1 meter then? The distance traveled by light in 1 by 3 into 10 to the power 8 part of a second in air or vacuum is called 1 meter. And meter also having, because units should be reproducible, it is having sub multiple, it is having multiple, it is having smaller unit or bigger unit. We'll come to the smaller and bigger unit of meter. Some smaller unit, some bigger unit, or some multiple, some multiple. We'll come to the smaller units here. If you look, centimeter, 1 cm, we know 1 meter equal to 100 cm, or 1 cm equal to 1 by 100 meter, or 10 to the power minus 2 meter. 1 meter equal to 1000 mm, or 1 mm equal to 10 to the power minus 3 meter. Micrometer, 1 micron equal to 10 to the power minus 6, so 10 to the power minus 6 meter. Nanometer, nano is used for 10 to the power minus 9, so nanometer 10 to the power minus 9 meter. 1 angstrom, 10 to the power minus 10 meter. Nowadays we are using nanometer, not the angstrom. So if we take the relationship between nanometer and angstrom, 1 nanometer equal to 10 angstrom. Fermi used for 10 to the power minus 15, that is, so 1 Fermi meter equal to 10 to the minus 15 meter. It will come to the bigger units, kilometer. 1 kilometer equal to 1000 meter, or 10 to the power 3 meter. Another one is the astronomical unit. Astronomical unit means The average distance or the mean distance between Sun and Earth, that is astronomical unit. Sun and Earth, how we will calculate the distance? By taking speed of light in air, 3 into 10 to the power 8 is the speed, and time taken for the sunlight to reach from Sun to our Earth surface, 8.3 minutes, nearly 8.3 minutes. By taking that 2, we can calculate and we will get the value 1 astronomical unit equal to 1.496 into 10 to the power 11 meter. Another one, the light year. The term light year means distance traveled by light in 1 year. In 1 second, light travels 3 into 10 to the power 8 meter. In 1 second it is, but in 1 minute into 60, in 1 day again, 1 hour again 60, 1 day then into 24, and 1 year 365 will multiply, will get the value 9.46 into 10 to the power 15 meter. Another one bigger unit, if we look, 1 parsec. 1 parsec is 3.26 light year or 3.08 into 10 to the power 16 meter, means some smaller unit, some bigger unit. To another basic fundamental quantity, that is our mass. We know mass is the quantity of matter contained in a body. Mass is the amount of substance contained in a body. Mass having the SI unit kg. And this kg also we can define by taking two definitions. First one, by taking platinum iridium alloy. In 1889, 1 kg was defined as the mass of cylindrical piece of platinum iridium alloy at 0 degrees Celsius kept at International Bureau of Weight and Measure. Means at that particular place of International Bureau of Weight and Measure, when they kept one cylindrical piece made of platinum iridium alloy, 90% platinum and 10% iridium, they got the mass of the cylinder as 1 kg. But with the change in place, with the change in temperature, again that all changed. For that reason, we got another definition of kg. 1 kg is the mass of 1 liter of water at 4 degrees Celsius, because we know density of water at 4 degrees Celsius 1000 kg per meter cube, and 1000 kg per meter cube is the density. It will take the volume as 1000 ml or 1 liter. We can change. We know that 1 ml equal to 1 cm cube, 1000 ml equal to 1000 cm cube. So 1 gram per cm cube density, volume 1000 cm cube. So mass equal to density into volume, d equal to m by v, m equal to d into v. So we'll get 1000 into 1 equal to 1000 gram, means 1 kg. This mass also having some sub-units like gram. 1 kg equal to 1000 gram, 1 gram equal to 1 by 1000 kg or 10 to the power minus 3 kg. 1 milligram, because 1 kg equal to 1 having 60 milligram. So 1 milligram equal to 1 by 1000 gram or 10 to the power minus 6 kg. People come to other smaller unit. One is AMU, atomic mass unit, which is used to measure the mass of one electron or atom. 1 AMU is the 1 by 12, the mass of carbon 12 atom. By taking the relative atomic mass, we can calculate AMU, value of AMU. 1 AMU equal to 1.66 into 10 to the power minus 27 kg. Next one will come the multiple units of kg, means the bigger units. 1 quintal, 100 kg. 1 ton, 10 quintals of 1000 kg. It will come the solar mass, the mass of sun. 1 solar mass equal to 2 into 10 to the power 30 kg, means some smaller units, some bigger units, to calculate the mass of any object. Third fundamental quantity is our time. LMT, length, mass and time. What is the time mean? Time means the gap between any two events, the starting point and the end point. Means where event start in which time and event stop in which time. That gap, a lifespan, if you look which gap what person born and which they die, that lifespan is the time. Time is the gap between two events. Time having the SI unit second, and this second also having sub multiple and multiple. But first, let to define this second. Second, we can define by taking a mean solar day, because 1 day 24 hours, 1 hour 60 minutes and 1 minute again 60 seconds, means 1 second 1 day equal to 24 into 60 into 60 equal to 86400 second, or 1 second equal to 1 by 86,400 part of a mean solar day. So we can define 1 second, and second also having some multiple, you can say, smaller units. 1 microsecond, sorry, 1 millisecond first, 1 millisecond 10 to the minus 3 second, 1 microsecond 10 to the minus 6 second, 1 nanosecond 10 to the minus 9 second, because nano micron, for 1 micron 10 to the minus 6, nano 10 to the minus 9, this is the prefix. And bigger units, if you look, 1 minute 60 second, 1 hour 60 minute or 3600 3600 second, and 1 day. 1 day means the time taken by Earth to rotate around its own axis once. The time in the rotation, Earth rotation take 1 day, which is 86,400 second time. So if we'll come to the other unit of time, in that we'll get one is week. Week or time period of 7 days. We know it is starting from Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So this all is a week, which is having 7 days. But when it come to a bigger unit of time, it's a month. We have a calendar, English calendar, which is mainly based on the revolution of Earth around Sun, and that English calendar having 12 months starting from January to December. Some are having 31 days, some are 30 days, and 1 month February, the smallest month, which is having 28 days. One more month we can say as a lunar month. Lunar month is different for different religion, Hindu calendar and Islamic calendar. Both the calendar based on this lunar month. Lunar month is the time taken by the moon to complete one revolution around Earth, or the amount of time it takes for the moon to pass through each phase, new moon, half moon, full moon. Again the same, means the revolution of moon around the earth is lunar month, and lunar month is nearly 29 days, we can say. And when it come to another bigger unit, that is year. Year in our English calendar, it is having 12 month, or which is around 365 days, but it's not exactly 365 days. That is the reason that after 4 years we'll get 1 day extra. That 1 day when we'll add to the year, that is called leap year. Leap year having the total number of days 366 days, and February month having 29 days. How to know which year is a leap year? If the year is divisible by 4, that is a leap year. But in case of millennium and century year, means 2000, 2100, 2200, 2300, 2400, 1 or 1000, 1900, 1800, this all century or millennium year has to be divided by 400. Then only we can say it is a leap year. So decade is a time period of 10 year, century time period of 100 year, and the millennium which is a time period of 1000 year. Means these all are the bigger unit of time. Now if we look here, one more part, the simple pendulum. Simple pendulum is used to know the time, the acceleration due to gravity of a place. Simple pendulum always tied or attached to a rigid support and having a thread, and at the last of the thread we will get a metallic bob. That metallic bob, which is free to move, it can oscillate, means where the mean position or the middle part is the mean position, and up to how much maximum distance is going either side, that is called as extreme position. So one is mean position, one is extreme position. In this simple pendulum if you look here, it is having a rigid support, and from the rigid support last it is having a metallic bob with the help of a thread. If you look the length starting from this point of suspension to the center of this bob is called the length, or simply you can say length of thread plus radius of this bob. It is called the length, and is free to move once both side will get extreme position and the middle part central position, mean position, or rest position. So once that pendulum move now mean to extreme, extreme to mean, again mean to extreme, extreme to mean, both sides, that is called oscillation. And maximum how much is going from its mean position to the extreme position, means from A point to B point or A point to C point, that is called amplitude. And for one oscillation means A to C, C to A to B, B to A. For this, how much time taken by a pendulum, that is called time period. And in 1 second, how much time a body vibrate, how much time a body oscillate, that is called frequency. So time period having the SI unit a second, frequency having SI unit hertz, and time period equal to 1 by f, or f equal to 1 by t. That is the relationship between time period and frequency for a simple pendulum. Simple pendulum time period is depends upon two factors. So discuss that all now. Now, on which factor this time period is depend, means from mean to extreme, extreme to mean, again mean to extreme, extreme to mean. It is taking some time. So on which factor this time period depend, means that time period will change for all the pendulum or it will remain constant. That one we are going to discuss here. First thing, it depends on the length. Means if the length of thread is more, that time will take more time. Means time period of simple pendulum directly proportional to square root of effective length, means length more, time period more. Length less, time period less. Another factor it depends is the acceleration due to gravity. If acceleration due to gravity is more, time period less. If acceleration due to gravity is less, time period more. Means in on the Earth surface, how much the time period of a given pendulum, on Moon surface it will change again because their acceleration due to gravity is not same. So here we got the relation. If we combine these two, t is proportional to square root of L, t is proportional to square root of 1 by g. So we got time period equal to 2 pi, one constant of proportionality used here because to equalize the proportion, we are using a constant. Here the constant is 2 pi. So 2 pi square root of L by g, where L is the length, G is the acceleration due to gravity. Next, if we'll square both sides, what we'll get? T square equal to 4 pi square L by g, because square root of L by g square equal to L by g. T square equal to 4 pi square L by g. So g equal to what we'll get? 4 pi square into L by t square. So this L by t square value, because time period of a simple pendulum is very less. For that reason, to find the L by t square, you have to take the help of a graph. Graph is a pictorial representation of a given data. Here you can see a graph between L and t square, L length and the x-axis, t square time and the y-axis, because t square is depending upon length. So here one more term used, the slope. What is slope? Change in y-axis means here 4.0 and here it is the 2.8, means this change in y-axis, how much change, because we are taking this much part from this point to the initial point, means the change in y-axis, this part, to the change in x-axis, means this value is called y2, here it is called y1, means the starting of y-axis is y1 and up to how much you are taking here, it is called y2. Starting point of x-axis is called x1 and up to how much you are taking, it is called x2. So y2 minus y1 by x2 minus x1 is the slope, and slope of this graph will get to find square root of L by g, and square root of L by g when we'll get, we can calculate easily the g for acceleration due to gravity. Acceleration due to gravity equal to 4 pi square by slope of t square versus L graph, means by using this graph how much we'll get our slope, that slope we can use here to find the value of g. Means by taking a simple pendulum, easily we can calculate the acceleration due to gravity of a place. Next thing here, time period of a simple pendulum is very less. For that you have to take some number of observation, number of oscillation, means 20 oscillation 15 second. One oscillation how much second, that one we can calculate by taking a tabular method we can take, or graphical method. In that means we have to take the number of observation, number of oscillation, because simple pendulum is taking very less time for one oscillation. For that reason, we are taking the help of this graph. Another one here, the seconds pendulum. What we can say the seconds pendulum? If time period of a pendulum is 2 seconds, means from mean to extreme, extreme to mean, again mean to extreme, extreme to mean. If it is taking 2 seconds, or frequency is 1 by 2 equal to 0.5 Hz. If we'll calculate by using this formula, we can calculate the length also. If we know the g of a place, we can calculate L, or L is nearly 99.2 centimeter or 1 meter. That is called a seconds pendulum. This is all about the measurement and simple pendulum. So for more videos, like my channel, you subscribe my channel, like my video, and keep your comment in the comment box. Thanks for watching my video. Thank you very much.